Hello everyone, so this is the very first video for our assembly language programming in Raspberry Pi 3. So in this particular video I will let you know how you can connect your Raspberry Pi with the remote desktop connection, and then we will write a simple assembly language program and how you can compile it or assemble it, and then you can run it on your Raspberry Pi machine. So first, what you have to do, you might have to connect with your Raspberry Pi with the separate power cable with the external keyboard, mouse and monitor. And once you open it, you have to open this terminal as this is here. I will just open the another window, so let's say so, and make it full screen. So, and if you want to increase the font size, you just have to press Ctrl Shift with plus, and the font will be increased. So now in case you want to connect your Raspberry Pi using the remote desktop connection afterwards, so what you need to do is you need to make some static IP settings with your wireless LAN. So you need some file with configuration here, so that is on this path. So Vim is the editor from which I will be using to edit the file, that configuration file. So that is on this path, Vim at etc/d at cpct.conf. so this is the file that contains the IP address settings. So at the very end of this file you have to add these settings under this command of the WLAN 0. So static IP address, here you can set it anything that you want, which should be according to your router gateway address. So in my case this is 192.168.18.1, and I have given it address 21. So let's say if I want to change this address for the moment, and I will just change it to 22. Alright, and I can then save this. So this file is saved but not yet quit. In case you are using the Ethernet LAN, then you have to make these changes here and in these sections. Alright, make sure you have commented this line out, which is no hook WPS applicant. Okay, so I'll just quit it. Now I have to reboot it, so these settings will be in effect. So when I will write this command, so you will see it requires some authentication from the admin side. So in that case I'll put sudo and then give it command sudo reboot. So you see now my device is rebooting. Alright, and I have now changed the static IP address, so I might have to change the address here. Alright, so I will change it to 22. So it will take some time when the device will go up again. So probably when you see some yellow light blinking on your Pi device, you might be able to notice that the device is up now. Now you can change this address here and simply press connect button here with the remote desktop connection. So it is connecting. Let's see if it gets connected. It should be. Okay, so it's still taking time, so we'll try again. Okay, so whatever the username and password is set for the devices, you will write here if there's any. Okay, so it is started now. So if you will see your if you hover the mouse over your Wi-Fi icon, you will see that this IP address is changed now. So it is now 18.22. Alright, so that means it's changed successfully. So this is the way you can change your IP address, and using this IP address you can always access your Raspberry Pi 3 device by using the remote desktop connection. And you just have to plug in the power cable with the USB port of your PC, and afterwards you can simply control it just like as a remote server. Alright, so I will just now open the terminal again, and we will see now how we can write the first assembly language program. So basically it is following the ARMv7 architecture and that instruction set, so we'll have to write some code here. So I just can increase the font size here so you can see. So I will just open the file using the Vim editor. You can use any default editor if you want to install the Vim editor. If it doesn't come up within the Raspberry Pi device by default, so always you can run this command sudo apt get install Vim. You can use this command if you want to install Vim. Otherwise, if you want to use any other editor, you can use it. So I will use Vim editor here, so I will say Vim. So for example, first I want to make the directory for my some assembly language stuff. So that is I already have created, so I will just make again. So mkdir space, I will name it assembly underscore prog. So it is created. I will just now change the directory. So currently my path is this /home/pi. so I will go into this, so it is created on this path, so I will go into this new directory. So I will just use cd command assembly _prog. So now my path is changed and I can see the new path. So here I will create the new file. I will say vim, let's say I name it first.s. Okay, so I will now try to insert some lines. So for example, if this is a just first program, I need to write some main section that can run. So I will, this is the instruction directory, so dot global, I will name it main. Okay, and I have to now define this main section, and in main what I can write here, I will write, let's say this command move r0 comma #2. So what this line is doing is simply copying the immediate value 2 into the register r0. So r0 is general purpose register, and we'll talk about more about the registers in the next video. So this is the command. Move is basically command just like the assignment operator in different languages. So this is the command you can use to move any values across the register. So this is the source and this is the destination. So this is the my mistake, this is the destination and this is the source here. So you can move this source into, copy the source into this destination here. So that's how this structure is followed. And next instruction is, I just want to exit the program, let's say. So I will write this instruction bxlr. So bx is branch instruction, so that's going to jump on the address that is being contained in the LR register, which is basically link register. So it is going to return the operating system back to the place from where this was started. So and whatever the value is moved in R0 register, you can always print it and see it on the console as well. So I will just save this program and exit this. So using the ls command, I can list the directory and files in my directory. So I have this file created here, first.s. Now I have to assemble it, so it can be assembled. So this is the command for assembling: as space first.s -o. So now my first.o is created. So this is the first binary that is that creates from the binary or byte file that creates from this assembler instruction. After that, I need to create the actual link executable file that can be run on this console. So for that purpose, we need to use the gcc command which is mostly used to compile the C programs as well. So I'll just need to compile this binary here so that the executable can be created. So I'll write gcc first.o, and I will say first So now I will list the files, so I can see that the file in green means that the executable is basically created. Now I want to run it, so I will run it like /. First, so when you run it like nothing will be printed, as I said that the value moved into the R0 just so you can see it. For that purpose we need a specific command after followed by first /first colon echo dollar and question mark. So then this command will run. Now the value will be printed here too. Alright, and in case you want to see a different values, you might need to first change the edit the file. So let's say I want to print 4 here, so I write 4 and save and quit the file. Now I need to assemble it again and compile it again with GCC, and we'll run this again. So now I can see the 4, and the different method here is, which is mostly followed by a lot of developers, that we create the makefile so that things can get easy specifically for assembling and compiling the programs. So this method will be like, you can create makefile by naming it makefile, vim makefile. Alright, and then what you will do is that you first have to like tell what you want to create. So first label all, you will give the file name that will be created. Actually, let's just like the link file, so executable file, so this name will be first, and then how the first will be created I need to tell it. So this is the command that I will just add here, gcc -o $rate this $+. Alright, and how this first .o is going to create, I need to tell it first .o space, so it's going to be created from the first .s and from the AS assembler command, AS -0 $@ space $, enter bracket, and now we can add the method to clean these files. For example, if the executables and binders are no longer required and you want to delete them, so like using the clean label, which we'll be using with the command as well, you can delete all these files, specifically the executables and binaries. So in clean you will write rm, which is basically command to remove the files, -bf first first means I will delete the first file, which is the name of the executable, and all the binaries. So static means that you want to delete all the binaries that were created with using the assembler or any GCC compilations. So that's how you do it, and I will just save it. So currently I have these files, so I will just write make clean. So these files are removed now, so I just have these two files, now make file and the first.s. Now I want to create those files again to run it, so I will simply write make instruction that creates all the files that were required. Okay, and now I can simply run that command to display the value. So here you can see. So so this was the very first video where we just wrote the program for assembly language. We just saw the values, how we can make changes in the program and compile it again using the make file as well. So make command and make clean command are being used with the make file that you can use to instead of like writing the long commands, you can simply make a make file, and you can use simple commands make or make clean to create them or to remove them, and afterwards you can run your program like this to display any answers that you want to see. So that's all for this session. In next video we'll be talking about the registers and the arithmetic instructions as well. Alright, thank you.